Hello everybody and welcome to Trig 6. So today we're going to talk about graphing other trig functions. So we're going to cover tangent, cotangent, secant, and cosecant. It's really important for secant and cosecant that we have a good understanding on how to graph sine and cosine because we use the sine and cosine graphs to help us graph the secant and cosecant graphs. And you're going to see that. First, we're going to start off with tangent and cotangent. So this is the first graph where we're going to see that it's not going to have a period of 2 pi. So we've already learned that sine and cosine repeat every 2 pi distance. Tangent, however, is different. Tangent repeats its graph a distance of pi. So every pi, or every half time we go around the unit circle, we're going to repeat the graph. Okay, so important stuff. The period is pi. So this is for tangent and cotangent. It has a period of pi. Every other function has a period of 2 pi. However, the vertical asymptote is at pi over 2. Okay, so let's think about this. We know tangent is equal to y over x. Okay, so when x is 0, tangent's undefined, which means that we'll have an asymptote. So if you think about the unit circle, at these points are when I have zeros and ones, right? So this first point is 1, 0. This next point is 0, 1. This one over here is negative 1, 0. And this one down here is 0, negative 1. Okay, so when x is 0, it's undefined. And when it's undefined, that means we have a vertical asymptote there. So I look at this unit circle graph, and if you guys see this, when is x 0? It's at pi over 2, or 90 degrees. So remember, this is pi over 2. And then this would be 3 pi over 2. Okay, so at those 2 points, I'm going to have vertical asymptotes. And then notice again, from here to here is half of a circle, or 180 degrees. And we know 180 degrees in radians is pi. So that's why our period is pi, because every 180 degrees, it doesn't work. So asymptote, 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 and it just keeps going like this. So that's why I have a distance of pi for these graphs. The period is pi. Okay, so it's important to know that our first vertical asymptote is at pi over 2. So I like to highlight my asymptotes, so I'm going to go ahead and draw in pi over 2. The next one I know is going to be at 3 pi over 2. Again, the distance between these asymptotes should be a distance of pi. So from pi over 2 to 3 pi over 2 is a distance of pi, so that is correct. And then we're going to just continue this pattern and go to the other side. So then we would have one at negative pi over 2 and negative 3 pi over 2. So what I remember for tangent, and it just helps me when I think about these graphs, tangent graph, I said like borders or surrounds or goes around the y-axis. So it borders the y-axis versus cotangent graph is going to be on the x-axis. Okay, so tangent graph borders the y-axis. Okay, so then we want to go ahead and start graphing some points. So we look at 0 first. So at 0 on our unit circle, which is right here, what would be my tangent? So again, tangent's y over x. So it'd be 0 divided by 1. 0 divided by 1 is 0. So I would have a point at 0, 0. Okay, the next one, or this spot right here, would be pi over 4, or 45 degrees, which is right here. And hopefully you guys know by now, pi over 4 is always root 2 over 2, comma, root 2 over 2. Okay, so when I put those over each other, root 2 over 2 divided by root 2 over 2, we get 1. So then I have a point here at 1. And now let's go to the other side. So let's go to negative pi over 4. And if I do negative pi over 4, I'm going to get negative 1. So then I have negative 1. This is what it's going to look like. This pattern is what it's going to look like in all of these sections or between all these vertical asymptotes. So smack dab in the middle, I have 0, 0, or a 0. It's on the x-axis. And then I go right 1, up 1. And then I'll go left 1, down 1. And this pattern will literally just keep continuing. So I'd have one here and here. That one goes off the page. In the middle, right 1, up 1, left 1, down 1, and here, and that one goes off the page. So it's the same between all of these vertical asymptotes. And then we connect this with a curve, and it's going to approach the asymptotes. So it approaches, it curves through here, and then continues down. So it approaches both of these asymptotes. So again, snakes through and down. Snakes through and down. Snakes through and down. And snakes through and down. Okay, and this is what a tangent graph looks like. So this is the parent tangent graph. There's no rights, lefts, ups, downs, stretch, shrinks. Okay, but just like anything in all the graphs we've ever learned about, the transformations remain the same on this. So let's go ahead, scroll down. So let's talk about the domain here. So the domain is our x's. So if you notice, right here it doesn't work, right here it doesn't work, right here it doesn't work, right here it doesn't work. Okay, so anywhere there is a vertical asymptote, it is not in the domain. So the first one that we have, talking about the positive side, the first one we would have is at pi over 2. And then it will keep repeating a distance of pi. So the way we write this is we would say theta cannot equal pi over 2 plus pi k. And k is just an integer. So k is an element of an integer. So that's saying if I plug in 0 for k, it would just be pi over 2. So pi over 2, I have a vertical asymptote. And then the next one, I plug in 1. So pi over 2 plus pi is 3 pi over 2. Have an asymptote. And then if I plug in 2, add 2 pi, so that would be 5 pi over 2 would have an asymptote. Over and over and over, forever and ever and ever. So that's how we write this to account for this continuous set of vertical asymptotes. Okay, do I have an x-intercept? Yes, I do. I do have an x-intercept. It's here at 0, 0, which would also be my y-intercept. Oh, that's my first one. And then I also have an x-intercept here, and I have an x-intercept here, and here, and here, and this will keep going forever. So we're going to kind of write it the same way. So my first one is at 0, and then it's going to repeat every pi distance. So that means 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, yada, 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 yada. So we would say our x-intercepts are pi times k. So I could put in 0 and get 0. I could put in 1 and get 1 pi. I could put in 2, 2 pi, 3 pi, 4 pi. And again, k is just an integer. So that would be all of my x-intercepts. I don't really want you guys to worry about odd symmetry. We're just going to skip that. Okay, now let's talk about our range. So our range is our y's. Okay, so our y's. This is coming from negative infinity, and then it's going to keep going towards infinity. So my range is just from negative infinity to positive infinity. Okay, and then my y-intercept would be right here at 0, 0. There is only one y-intercept. Okay, asymptotes occur everywhere the domain doesn't work. So our asymptotes are at x equals pi over 2 plus pi k. And again, k is an element of integers. Okay, so that is our tangent graph. So now we're going to talk about some transformations on my tangent graph. So these are the same transformations we've been learning for a long time. Negative out front is a reflection across x. The 2 is a vertical stretch. And then this is really 1/2 times x. This is going to change your period because this is a horizontal stretch or shrink, but we don't call it a horizontal stretch or shrink. What it's going to do is if I stretch this or shrink this, it's going to move my period. It's going to move my vertical asymptotes, change the period. So we call this a period change. All right, so what is my new period? So what you guys do is you take your normal period. So normally the period of a tangent graph is pi. And then we divide it by whatever's being multiplied by x. In this case, it's 1/2. So keep, change, flip. I end up getting pi times 2/1, which equals 2 pi. So now my period is going to be a distance of 2 pi. So between all of these vertical asymptotes, it's going to be a distance of 2 pi. Okay, so to find your first one, so remember it's going to border evenly, it's going to border your y-axis. So this is where it's normally at with a distance of pi. Well, I need to double this distance, so I'm going to double it on each side. So pi over 2 plus pi over 2 gives me pi, and negative pi over 2 minus pi over 2 would give me negative pi. So my new vertical asymptotes are at negative pi and positive pi. And again, we should check, does this have a distance of 2 pi between these periods? And yes, from negative pi to positive pi is a distance of 2 pi. So that's honestly the only ones that even fit on this graph. Because then my next one would be over here at 3 pi and over here at negative 3 pi. So those don't even fit on our graph. Okay, so what I always do is in this tangent graph, smack dab in the middle is your 0, your x-intercept. Okay, and then I have here and here. So it's really split up into fourths. 1, 2, 3 fourths. So whenever you change your period, just go in here and split it up by fourths. So I make myself little marks. So here's smack dab in the middle. Now go to this lower half, and you're gonna split that right in the middle. So that's here. And then you're gonna go to this upper half, split that in the middle, and that would be here. So these are the 3 main spots that we have to graph. Okay, again, for this one over here, this would be the middle, split this in half, I would be here. And this would be the middle, split it in half, there. Okay, on the middle one, so because this didn't shift up or down or anything like that. So on the middle one, we're going to have our zeros. So go to the middle ones and put your zeros in. Okay, normally tangent goes. Normally it goes over 1, up 1, and then it goes left, down. Okay, because the normal graph looks like, oh, that was a bad example. Man, I can't, like that. Okay, so that's our normal graph. So this is the direction. I always say the right side is high, left side is low. But I have a reflection across x, so it's going to flip it to this direction. So it's going to flip it to go left side is high and then the right side is low. Okay, so we're going to flip it. And then we're vertically stretching by 2. So normally I go right 1, up 1, left 1, down 1. But now I'm going 2 because I'm vertically stretching by 2. Okay, so taking all of that into account, so now I'm going to go left 1, up 2 because it needs to come this direction. And then to the next tick mark, down 2. So this would be here, and this one would be here. Okay, and then again, we're going to approach and connect. Put arrows on both sides, approach and connect. And approach and connect. So that's what this graph would look like. So kind of a lot going on. It's not unbearable. So step 1, find your period, find your asymptotes, split it into fourths. So split it in the middle, then split in the middle, split in the middle to get your main spots. And then just do your transformations, whatever you have. Okay, so let's look at B. So here's graph B. So let's talk about the things that are happening here. So this is being multiplied to my x. This is going to change my period again. It's on the inside of the function, that changes your period. If it's on the outside, if it's being multiplied to the outside, then it is vertically stretching, inside changing period. Plus 2 on the outside, you guys should know that's going to move it up 2. So we kind of have this like midline. I call this the midline. The x-axis is normally the midline. So we're going to end up moving that midline up 2. And now this will be your new like midline. All right, so let's get our new period. So ask yourself, what is tangent's normal period? Tangent and cotangent have a period of pi. So we're going to get pi. And then you're going to divide by whatever is being multiplied to x. This one's a little weird. We're multiplying by pi over 4. So keep, change, flip. I get pi times 4 over pi. And what's going to happen is my pi's are going to cancel. So I just get 4. So now I have a period of 4. Okay? Don't freak out. Still fine. No big deals. This is still radians also. Because you got to think, pi is just a number. So we just simplified by a number and we just got rid of the pi's. So now we have a period of 4. So between each of our asymptotes, there should be a distance of 4. And notice this graph is nice and it already has it set up for us like that. Tangent graph borders the y-axis. So if I have a distance of 4, ultimately you're just doing 4 divided by 2. And that's going to give me 2 and then negative 2. So again, this still has my distance of 4. 1, 2, 3, 4. And then we're going to do the next one, distance of 4. So that would put us on 6 and negative 6. So I can see 3 full periods in this graph. Okay, the next thing that happened is it shifted up 2. So we're going to draw like just a little, like this is our new midline. New midline. So just kind of make a dashed line. This is the new midline. Okay, and then like normal, and this one's easy, so go smack dab in the middle, make a mark, cut the other half in half, and the other one. So this one's nice because it's just already on the normal spots. Okay, so now go to your midline, and then smack dab in the middle of your midline is where your points are going to be. Okay, so that's like your new 0. Those are like your new x-intercepts. They just got shifted up 2. Okay, and then what else is happening? Nothing else happened. We shifted it up 2. We changed the period. So now the pattern of the graph is still the same. We're going to go right 1, up 1, left 1, down 1. So right 1, up 1, left 1, down 1. Right 1, up 1, left 1, down 1. So we have these. And we're going to approach and approach. Approach and approach. And approach and approach. And that would be your new graph. Oh, I forgot to write our period is 4. Okay, so that's the tangent graph. Cotangent, very similar. Just the only difference is the initial vertical asymptote is now going to be on 0. And instead of going in a positive direction, snakes in a positive, it's going to snake in a negative direction. So example 3. So now we're going to be talking about cotangent. So again, it's still very similar to tangent. It still has a period of pi, but our first one is at 0, and then our second one is at pi, our asymptotes. Okay, reason being, again, thinking about our unit circle here, cotangent is x divided by y. So we have asymptotes when y equals 0, we get vertical asymptotes. So again, where we have zeros are right here on our axes. So this is 1, 0, this is 0, 1, negative 1, 0. and 0, -1. So again, I'm looking for when is y 0 now. So y is 0 here and here. So that means my asymptotes are here and here. On the unit circle, that's at 0 and pi. So that's why my asymptotes are at 0 and pi. So we have 0 and pi. Again, it's still going to be a distance of pi away because the period on cotangent and tangent is pi. So all my asymptotes are a distance of pi away from each other. And then the only difference is, again, this is going to be snaking in a negative direction instead of a positive direction. But other than that, same. So you go right in between your vertical asymptotes, put your middle one. Okay, now you're going to go left one, up one. And then you're going to go right one, down one. Approach and approach, snake it through. And this is your cotangent graph. Okay, so again, how I remember the difference is tangent borders, the asymptotes border the y-axis. Cotangent, it's on the y-axis. Tangent, positive snake. Cotangent, negative snake. Those are the main differences between tangent and cotangent. All right, so let's go ahead and answer these questions. So again, talking about our domain doesn't work every place that there is a asymptote. And if you notice, the asymptotes are now on pi, 2 pi, 3 pi, 4 pi, 5 pi, da-da-da-da. So it's everything except theta cannot equal pi k. Again, k is an element of z, so that's saying 1 pi, 2 pi, 0 pi, which is 0, negative pi, negative 2 pi, negative 3 pi, yada, yada, yada. Range, again, is our y, so it goes from negative infinity all the way to positive infinity. There's no breaks this direction. So, negative infinity to positive infinity. My x-intercepts, if you guys notice now, they're at the pi over 2. So pi over 2, 3 pi over 2, negative pi over 2, 3 pi over 2. So my x-intercepts are at pi over 2, and they're all a distance of pi away from each other. So plus pi k. And again, k is an element of z. Y-intercepts. This guy does not have any y-intercepts because there is a vertical asymptote on the y-axis, so no intercepts or none. Don't worry about odd symmetry. It's just telling you it has odd symmetry. And then we have our asymptotes. Our asymptotes are everywhere our domain doesn't work, so my asymptotes are at x equals pi times k. Again, k being an element of integers. All right, so let's go ahead and graph some cotangents. Okay, so the only thing happening to this one is there's something being multiplied by x. If there's something being multiplied to your x, this is a change of period. So it changes the period. That's the only thing happening to this. I'm changing the period. Normally, my period is pi. You're going to divide it by whatever's being multiplied by x, in this case, 2. So my period is pi over 2. Okay, so again, for cotangent, it's always going to start on the 0, unless there's a right-left shift, of course, but there's not. And then now we're going to go a distance of pi over 2 for the next one. So it's horizontally shrinking. It's getting squished horizontally. So go ahead, draw all those in. All right. Nothing else has changed. So smack dab in the middle is your zeros. So go to the middle of all these and put your zeros right in the middle. Okay, this one we're just going to have halves. So you're splitting this distance in half. So I'm going right here, and I'm going left one, up one. Then I'm going here and down one. So my points are going to be fairly close to each other. Should look like it horizontally shrunk. Connect, connect. You know what? I'm going to show you guys that I'm going just right between, and that's where these are going, right between. Okay. Continue the pattern. And connect these. Again, these should never touch or cross. It just approaches, gets real close, but shouldn't touch it or cross it. And voila. All right, let's look at the next one. So I have a negative out front. So instead of this having a negative snake, now it's going to be a positive snake. So it's going to look more like a tangent. So that's our reflection across x. Okay, pi over 2 is being multiplied to x. That's going to change my period. And plus 1 is going to shift everything up 1. So I'm going to have like a new midline. All right, so let's go ahead and change our period. So standard period is pi. We're going to divide it by whatever's being multiplied by x. So we're going to divide by pi over 2. Keep change flip. So keep pi times 2 over pi. Pi's will cancel, so we get a period of 2. Okay, tangent or cotangent graph starts on the y-axis for the asymptotes, and then we'll go a distance of 2 away for all of the following ones. So it should have a period of 2. Between all these asymptotes, there should be a distance of 2. Okay, it's going to reflect, so that just means it's going to snake in a positive direction now. And then everything's getting shifted up 1, so I have a new midline. That is up 1. Okay, so again, go in between, smack dab in the middle of all these vertical asymptotes, and put your quote-unquote zeros. Obviously, all of these are moved up 1, but you still get it. So put them on your midline. Okay, again, you're going to go right 1, and now we're going to go up 1. It's going in a positive direction. Splitting that area perfectly in half. And then connect and snake. Oh, that last one was bad. Perfect. So that is our tangent and cotangent graphs. So next we're going to talk about secant and cosecant. In order for us to be successful at secant and cosecant, you have to be strong at graphing sine and cosine. Because literally secant and cosecant is graphing sine and cosine, and then we just do a few extra little things to it. But really, to get these graphs, you're just graphing sine and cosine. So you're not learning too much new stuff on these. All right, so we're going to go ahead and talk about cosecant first. So you need to know what is its reciprocal function. So cosecant's reciprocal function is sine. Y equals sine theta. And I always remember, again, for these, C and S go together, and then C and S will go together. So that's how I always keep these straight. So the domain of, you know what, we're going to graph it first before I even talk about domain. So we're going to just start by graphing sine graph, okay? Sine graph, you should know it. Sine starts at 0, 0, and then it goes up, back to 0, down, back to 0. And this has a period of 2 pi. Cosecant and secant will also have a period of 2 pi. Okay, continue this pattern to get my wave all the way. Okay, so now what you're going to do is you're not going to connect this with a solid. This is just the outline to give us this cosecant graph. So I want you guys just to get in the habit of connecting this with like a dotted line, just so you know, like this isn't a real graph. This isn't part of the graph. We just use this to help us get the graph. Okay, so we should have this nice wave. Beautiful. So every time there's a 0, so every place there's a 0 on this graph, or an x-intercept, you're going to draw on a vertical asymptote. So I have a vertical asymptote here, a vertical asymptote here, one here. So every time it's 0. So I also like kind of imagine that I'm like bordering each hill and valley. Like you're bordering each hill and valley. And then the actual cosecant graph is you go to the top of each hill or to the bottom of each valley at this point right here, and then you draw little parabolas that approach your asymptotes. And that is the actual cosecant graph, is these little parabola pieces. Okay, so that is my cosecant graph. The blue is the cosecant graph. The sine graph I use to get this is like imaginary. So now we can talk about the domain of this. So the domain is every place that there's a vertical asymptote, theta is not going to work. So theta cannot equal, and it goes 0, pi, 2 pi, so it's pi k. And k is an element of z. The range is, okay, so let's look at each one. We're looking at the range. So it goes from negative infinity, and then it stops at -1, right? And then from -1 to +1, there's nothing. There's nothing in this box. So it goes from negative infinity to -1, stops, jumps, and then it starts again at 1 and goes towards infinity. So that's literally my range. So I'm going to go negative infinity to -1. -1 is included. That is a solid point there. Union, and then 1 to infinity. So it has a jump. And then my asymptotes are everywhere my domain doesn't work. So my asymptotes are at x equals pi k. K is an element of z. All right, so now let's talk about the secant graph. So it's going to be very similar to cosecant, but now instead of using the sine graph, we're going to use the cosine graph. So the reciprocal is y equals cosine theta. So you're going to go ahead and graph the cosine graph. So cosine starts up 1, 0, down 1, 0. So go ahead, draw in your cosine graph. And then again, you're going to use dotted lines to connect it, because technically this isn't part of the graph, of the final graph. This is like imaginary. All right, so I have this graph. And then just like our secant or our cosecant graph, every time there's 0, you're going to put a vertical asymptote there. So you're bordering hills and valleys. So you should have hills and valleys between each vertical asymptote. Okay, let's talk about why this makes sense that there would be vertical asymptotes here. Okay, because this is a reciprocal function, secant is really 1 over cosine. So if cosine is 0, 0 is technically over 1, 0 over 1 is 0. And if I were to flip it, I would get 1 over 0. Well, 1 over 0, we can't have zeros in a denominator, so now it's undefined. And that's where these vertical asymptotes come from. And then just like before, we go to the top of every hill and valley, and you're going to draw yourself little parabolas that will be approaching each vertical asymptote. And that is the secant graph. So really, as long as you can graph sine and cosine, you can do secant and cosecant. Okay, so the domain of this is everything except for where those vertical asymptotes are. So it's theta cannot equal, and they're at pi over 2. So pi over 2 plus pi k distance. K is an element of z. Our range, just like our cosecant graph, it goes from negative infinity to -1, -1's included, union, picks back up at 1 to infinity. And then our asymptotes are everywhere that the domain can't happen, so our asymptotes are at x equals pi over 2 plus pi k distance, and k is an element of z. All right, so let's go ahead and look at these functions. So the first thing we want to know is what's the reciprocal function. So you guys are literally going to just, instead of writing cosecant right there, you're going to change it to its reciprocal function, which is sine. So this is really y equals 2 times sine of x over 2. This is the sine graph you graph to get this cosecant graph. Okay, let's talk about things that are happening here. This is going to vertically stretch by 2. So now my wave, instead of going up 1, it's going to go up 2, my wave. And then this is going to change my period. So again, my period for sine and cosine is 2 pi. You're going to divide by whatever x is, whatever is being multiplied to x, which is 1/2. So we're going to get 2 pi times 2 over 1, which equals a 4 pi. So now my period is 4 pi. Okay, so for that, I just always like to, again, kind of make those tick marks. So whole period's 4 pi. I cut that smack dab in the middle. That's 2 pi. And then I cut both of those in the middle. So middle and middle. So these are my main spots that I should be hitting for my sine graph. Okay, sine graph starts at 0, 0. 0, 0. This one, instead of going up 1, it's going up 2. So where my marks are, it's now going to be at 2. Continue the pattern to the other side. Okay, so this is my sine. This is y equals 2 sine of x divided by 2. Again, this is an imaginary graph right here, so you're just going to put little dots. Like so. Okay, every place there's a 0, there is a vertical asymptote. So, again, bordering our hills and valleys. And then once you got that, you go to the top of each hill, to the bottom of each valley, and you draw yourself a parabola that should approach each asymptote. And that would be my cosecant graph. All right, so looking at this one, write your reciprocal. So I'm going to get y equals -2. This is now going to be a cosine of 3x. Negative is going to reflect my wave. So instead of starting high, up 1, you're going to start down 1. And then 3 is going to change my period. So let's change our period. So we're going to get 2 pi divided by whatever is being multiplied to the x, which is 3. Can't simplify that, so it's just 2 pi over 3. Which again, this graph is really nice because it gives us those spots. So again, I just like doing the little marks. So here's a full period from here to here. Go in the middle, cut it, go in the middle, cut, cut. So this one's nice. It's on all of the ticks already. Okay, so instead of starting high, I'm starting low. And instead of starting up 1, I'm starting up 2. So now I'm starting down 2 because of that vertical stretch by 2. And then I go back to 0, up 2, back to 0, down 2, back to 0, up 2. Just continue your pattern. Both directions. Okay, so this is my cosine graph. You're going to connect this with little dots because, again, this is imaginary. This isn't really there. All right. Now we're going to go put in our vertical asymptotes. Every place there's a 0, there goes a vertical asymptote. Vertical asymptote. There's quite a few. We have quite a few periods here. All right. And then once we're here, hills, valleys, you put little parabolas on the tops and bottoms, and they should approach. So they're going to be kind of skinny. And that would be your graph. Okay, so hopefully this is making sense. Again, this is why we have to have a strong base in sine and cosine, because really the hard part is graphing the sine and cosine. Once you figure out the sine and cosine, it's really easy to get the secant and cosecant. Did I write my period? Yeah, I did. Okay, so now let's go to the next page. Let's talk about this one. So this one, I like this one because this one is going to give us a horizontal shift. And we don't see it as often. So this is going to shift it horizontally. So let's talk about all the things happening here. So again, the 2 out front would be a vertical stretch. There's nothing being multiplied to my x. So my period's going to remain 2 pi. But this is on the inside, opposite of what you think. So this is going to actually shift my whole graph right pi over 2. So everything's being shifted right pi over 2. Okay, so what is my reciprocal graph? It's going to be y equals 2 sine of x minus pi over 2. Okay. What is my period? My period is not changing because there's nothing being multiplied or divided by to my x, so it's going to remain 2 pi. So again, sine, cosine, secant, cosecant has a period of 2 pi, tangent, cotangent, period of pi. All right, so we can easily graph this. So the only difference is normally, so we kind of have to use our imaginations, right? Normally, sine starts at 0, 0, but everything's going to shift right pi over 2. So this right here is my new starting point. So this is my new starting point. New starting point. Okay. And the period is 2 pi, so it's going from pi over 2 to 5 pi over 2. I just did 2 pi plus, or I did 2 pi plus pi over 2, so I got 5 pi over 2. So this is one whole period. So from here to here is one full period. And then again, just cut it in half in the middle, which would be here. Cut that in half and cut that in half. Those are your main tick marks. So I'm going to go ahead and do that. So I start here, and then I'm going to go up 2 because it's vertically stretched, back to 0, down 2, back to 0, up 2. So now you guys can just continue your pattern. Oops, wrong spot. Okay, and then I have my sine graph. Again, this sine graph is technically imaginary, so we're going to just put in this dotted sine graph. Okay, every place there's a 0 goes an asymptote. Okay, and then tops of the hills, bottoms of the valleys, little baby parabolas. And that's what this graph would look like. All right, last but certainly not least. Okay, this is really important. I want you guys to pay attention to this. And it's just like when we do any transformations. So if there is something on your x, you need to factor it out. The reason we have to factor it out is because that's the way that we see our horizontal shift. If we don't, you guys go, oh, we're shifting by pi. No, we're not. We're actually shifting by pi over 2. So you always have to be careful about that. Factor out that number if there's more than one thing in there. You need to factor it out. So there is always a 1 on the x. All right, so now we can answer all these questions. So what is my vertical shift? So vertical, my up, down. This guy is going down 1. What is my phase shift? So that's your horizontal. What's your right, left? It's called a phase shift. So my right, left, this is going right pi over 2. Right, opposite of what you think. What's my horizontal transformation? In other words, your horizontal transformation means what's your period change? So I will be changing my period. I'll be doing 2 pi divided by what's being multiplied, which is 2. So now the period on this is pi. And then we're going to graph the reciprocal function. So the reciprocal, opposite of secant, cosine. So y equals negative cosine of 2 times x minus pi over 2. And then minus 1. All right, so let's graph that. So first off, my midline is being shifted down 1. So kind of draw in your new midline. Okay, so cosine, we usually start up at 1. Okay, so normally I start up at 1 for cosine. So in this case, from the midline, I'm up 1. Okay, so I'm right here. We want to phase shift this pi over 2. So we want to move over pi over 2. So now my new starting point is here. Okay, so now my new starting point, oh, but I made a mistake here. My period is now a distance of pi. So it's getting a little weird here. So let's figure out our distance of pi. So here's my distance of pi. Okay, my new starting point, I'm supposed to shift everything over pi over 2. Okay, so everything is shifting over pi over 2. So I'm starting here. So let's make our ticks. That will help us. So we're starting here, pi over 2. Our period is pi, so that would take us all the way to 3 pi over 2. Split in half. Okay, so that's nice. It's right on where all the ticks are already at. And then we have a reflection, because we didn't write it down and I didn't see it. So we have a reflection. So instead of here starting up 2, we're actually going to start down 2. So this is my technical starting spot right there. Okay, and then we go back, oh, not 2, down 1. 1. Sorry, there's no vertical stretch or shrink on this. So we're actually starting down 1. There we go. And then we'll go back to the 0, up 1, back to the 0, down 1, back to the 0. Continue this pattern. Here. And this one's kind of confusing because it looks just like a normal cosine graph. Here's the 0, starts up at 1, and it's pretty much like the normal cosine graph that just been shifted down 1. So this is good. We reflected it. We started in our new spot. So go ahead, connect this with your dotted lines. Okay, everywhere there's a quote-unquote 0, or where it's on the midline, there is a asymptote. So again, bordering our hills and valleys. We are bordering our hills and valleys. Okay, and then we put in our little parabolas. And that can finish our graph. All right, have a great day, everybody.